After the world's most catastrophic group project ended in 1945, the two remaining team captains, America and the Soviet Union, had a lot of captured German scientists to deal with. Instead of holding them accountable for building weapons of terror, they did the sensible thing: offered them jobs. The Americans called their program Operation Paperclip, which sounds like a cute office supply initiative, and got the big names like Wernher von Braun. The Soviets ran Operation Osoavia Him, rounding up thousands of lower-level technicians, because if you can't get the head chef, you might as well grab the entire kitchen staff. And so began the race to see which ideology was better at pointing someone else's terrifyingly effective rockets at the sky instead of at London. On October 4, 1957, the Soviet Union launched a 184-pound polished metal ball called Sputnik 1. It did exactly two things: orbit the Earth and beep. That's it. But that simple beep, broadcast on shortwave radio frequencies anyone could pick up, was the most terrifying sound the American public had ever heard. It was a constant, orbiting reminder that the people they'd been told were backwards communists were currently flying over their houses every 96 minutes. The resulting panic was so profound, it led to the creation of NASA and the National Defense Education Act, which pumped money into science education. All because a metal sphere went beep beep from really, really high up. Before strapping a human to a glorified firework, both sides needed to see if a living creature could even survive space. The Soviets, ever the romantics, chose stray dogs, figuring they were already accustomed to hardship and indifference. The most famous was Laika, a very good girl sent on a one-way trip aboard Sputnik 2, a mission designed without a re-entry plan. The Americans preferred chimpanzees because they're closer to humans, which makes it both more scientific and slightly more disturbing. Ham the chimp was trained to pull levers and was rewarded with banana pellets, proving that even in the cosmos, middle management principles apply. He survived his flight and retired to a zoo, presumably with a deep-seated distrust of levers. On April 12, 1961, Yuri Gagarin squeezed into his Vostok 1 capsule and became the first human to orbit the Earth. He was a charismatic 27-year-old with a killer smile, the perfect poster boy. Upon seeing the Earth from orbit, he supposedly said, "I don't see any God up here," which was a fantastic line for an officially atheist state, though it's heavily debated if he actually said it. The U.S. response was to launch Alan Shepard on a suborbital flight a few weeks later. He went up and he came down. It was less of an orbit and more of a cosmic pop fly, but America desperately needed a win, even a small one. The Americans, with von Braun's team, developed the Saturn V. It was a 363-foot-tall masterpiece of controlled violence, the most powerful rocket ever successfully flown. Its 5 F-1 engines burned 15 tons of propellant per second. The Soviets, on the other hand, had the N-1 rocket. Lacking the ability to build massive engines, their chief designer, Sergei Korolev's successor, Vasily Mishin, decided to just strap 30 smaller engines to the bottom of a giant tube. It was a plumber's nightmare. All 4 launch attempts of the N-1 ended in catastrophic, earth-shaking explosions, one of which was the largest non-nuclear man-made explosion in history. Turns out, getting 30 engines to agree on a direction is harder than it sounds. Navigating to the moon required a computer. But this was the 1960s. The Apollo Guidance Computer, or AGC, had a processor that ran at 2.048 megahertz and had about 248 words of RAM. Your singing birthday card has more computing power. Seriously. The software, which was woven into memory banks by hand using copper wires, was a marvel of efficiency. Margaret Hamilton led the team that wrote it, pioneering the very concepts of software engineering to make it work. During the Apollo 11 landing, the AGC was overloaded with data from a misaligned radar, but the software was smart enough to prioritize the important landing tasks and ignore the junk. It's the only reason Neil Armstrong didn't become a permanent lunar art installation. You've probably heard the story. NASA spent millions developing a pen that could write in zero gravity, while the clever Soviets just used a pencil. It's a wonderful tale of bureaucratic idiocy versus simple pragmatism. It's also completely false. NASA initially used pencils too, but they had two problems. The tips could break off and float into equipment, and pencil lead is flammable graphite, which isn't ideal in a 100% oxygen environment. The famous space pen was actually developed privately by Paul Fisher of the Fisher Pen Company using his own money. He then sold them to NASA and, later, the Soviet Union for a few dollars apiece. So the real story is about a smart capitalist solving a problem for everyone, which is somehow less fun. While the public was watching moon landings, the real action was in low Earth orbit. Both sides were furiously launching spy satellites. The American Corona program was a masterpiece of convoluted engineering. A satellite would take pictures on actual film, then eject a bucket containing the film canister, which would re-enter the atmosphere. Then, a C-119 flying boxcar aircraft had to literally catch the bucket's parachute in midair. What could possibly go wrong? The Soviets had their Zenit satellites, which were brilliantly designed to be dual-use. The same basic spacecraft could be used for spying or for sending a person into orbit. It was efficient, clever, and a constant reminder that the grand adventure of exploration was also about making sure you had very clear pictures of the other guy's missile silos. The ultimate justification for spending billions on this celestial staring contest was the technology it created for the rest of us. No, NASA didn't invent Teflon or Velcro, those are other fun myths, but they did pioneer things that matter. The need for shock-absorbing seats for astronauts led to memory foam. The need for portable tools on the moon gave us better cordless drills. Freeze-drying technology developed for space food means you can have terrible, crunchy camping meals today. And most importantly, the entire global network of communication satellites, GPS, and weather forecasting is a direct result of the infrastructure built to yell at the moon. So next time you use Google Maps to find the nearest coffee shop, you can thank Wernher von Braun and Cold War paranoia. After a decade and a half of near misses, explosions, and astronomical budgets, the two rivals got tired. In 1975, the Apollo-Soyuz test project happened. An American Apollo module docked with a Soviet Soyuz capsule in orbit. Astronaut Thomas Stafford and cosmonaut Alexei Leonov met in the middle and shook hands, a hugely symbolic moment broadcast around the world. It was the official end of the space race. It was a beautiful moment of détente and international cooperation. It was also an admission that trying to bankrupt each other to prove a point was, perhaps, not the most sustainable model for exploring the universe. They finally figured out it's easier to just share the ride. If you enjoyed this video, please like, comment, and subscribe to our channel for more historical insights. Thanks for watching, nerds!